So today, what I'm going to talk about is our take on UI components on Android and how we have been using that in our consumer application. I was in the last Droidcon in New York City, and I spoke about how we rewrote a player using UI components. And today I'm going to talk about what changed since then in the other place that we are using that now in our application. And one more question, who here is not from the Bay Area? Wow, all right. Who here is not from San Francisco? Still Bay Area, but not from San Francisco. Okay, for everybody that raised your hand, tomorrow you probably are going to have a big commute living here. So one thing that you could do is you could use the Wi-Fi and download some shows. Then you can watch using our Android application. And also, next time you do that, you are going to know exactly how it works and how the code works, how the architecture all fits together, and you are going to see all the UI components that I'm going to talk about. All right. A little bit about UI engineering at Netflix. We have an organization that our main responsibility is to write different user experiences and do A/B tests. If you're not familiar with A/B tests, what it means is we have a screen that everybody sees one user experience, but we work to improve that experience. And sometimes we have 3 or 4 or 10 different experiences in the same screen, and we ship that to multiple different users. So we track the data, and in the end, we are going to know which experience performs better and which experience the users like more. And that's the one that everybody gets. The technical challenge with that is how do we code and how do we handle this thing? It's a little bit complex, and this is an example to illustrate that. If you look here in your right, you can see how our old player UI used to be. And then we worked, some time ago, we worked in an A/B test that had a lot of different variations of that experience. And we shipped that to a lot of users. We got the data, and in the end, we shipped a new experience. That's the one that I hope everybody is familiar with. And one difficult part about that is, if you look in these illustrations, the orange boxes are UI elements that we need to move around. We need to add new elements. We need to remove some. And it's a little bit complex to implement that because everything has to work, and we cannot break the existing experience that most of the users are using it. So how do we code that? There are some approaches that you can take to solve this problem. One approach would be you can have a giant XML layout that has all the experiences in one layout, and then you have some code that is going to provide the correct user experience for the users that you want. The problem with this approach is your code needs to handle all the Android views. You might have 100 Android views that you need to show and hide and to provide a specific experience for a user. And you can have some bugs like you show 2 buttons, one in the top and one in the bottom that do the same thing because you had a bug in your code. Or perhaps you could approach that in a different way. You could have one XML per user experience that you want to provide. And in this scenario, the problem is you might have a lot of code duplication because the experiences are similar. You are going to create 10 different XMLs, and if you need to change a padding in a button, we probably need to change in a lot of different places. Or you could consider using programmatically layout, which is also possible and also exists. But this is only about the layout. What you do with the business logic? One approach, if you have a master XML, you probably are going to have a master fragment that has to deal with that. And then you are going to have to inflate all that views and show that to provide the experience that you want for the specific users. Or you could do a little bit better. You could have one class per experience that you want to provide and organize a little bit better using composition or maybe inheritance. But the way that we approached this problem is we decided to try out a componentization approach. So what we did is we got the UI and we split that in different small components. And the components are not Android views. They could be one or more Android views that make sense in the layout or in the business logic aspect. One good thing with this approach is each test variation, each different user experience, you can have its own component, and you can reuse the components. If you have 3 or 4 cells that you want to ship to users, you might use the same components and put them in different places. And also, you don't need a giant XML. You can have a small XML that represents that component, and then you can lay out in a different way. So the question is this one more architecture that I want to push through? The answer is it's not. It's not about introducing a new model view, whatever, architecture, because we have a lot of these things, and everybody has the one that works better for your use case. The real thing that we want to bring is the real contribution that we want to provide is the idea of UI components. And we believe that it will provide reusability and testability. And these are 2 very important things for us. We should be able to test independently a small UI portion using unit testing, and you should be able to have a good coverage without having to deal with 100 dependencies and be able to mock life cycles and activities and all these things. It should be pretty simple, and then it will encourage us to test more our code. So one thing that I would like to say here is the fragment should not be your view. There are a lot of different thoughts about that in the community. If you consider that the fragment is your view, it means that the fragment does a lot of things. It is responsible for the life cycle. It talks with some service or etc. and also has to inflate all your Android views and deal with that and set the properties on that. The fragment should take care of the life cycle. And also, one more thing is Android views are not reusable. I'm saying it now, and a lot of people should be looking at me and thinking, this guy is crazy. I can totally reuse an Android view. The point that I want to make is you can have a text view that you have in an XML, and then you copy and paste to another one. But think about a more complex component that you have in your UI. The Android view is a very small portion of it. You need all the business logic and the presentation logic that will make that component work. And where do you put that? Probably it is in your fragment, and then if you need to reuse that thing in another fragment or in another activity, you will have to copy all that code, and that's not super reusable. So here is an example how we approached the player UI with the components. And what I just said apply to that small icon in the upper corner that it's our cast icon. So that's just an Android view, it's a button. And you could copy that from one XML to another, but this component requires a lot of code to work. What we need to do is we need to verify in your Wi-Fi all the TVs that you have connected, and when the user taps on that, we need to show a list of possible targets. In all this code, it needs to live in a place that you can easily just put that in another screen if you need to. And that's what I meant with reusability. But also here we have some other components that we decided to group by the center controls, and we have some progress bar that updates for every second. We have some buttons in the bottom. But also we have more stuff in the player. We have a loading component that we need to show when the playback's buffering, that we don't show when it's playing. And we also have a complex thing that we have in the end of the playback that we allow the binge watching that we play automatically the next episode and all these things. And this UI, it should show up in the right time. And all this logic it should be embedded in that UI. So what else? What else do we have this use case in our application? Here is one example. When you are in the home screen on Netflix and you tap in a title, we show this detail page that has a lot of information about this title. One thing that we have here highlighted is the season selector. And this is, it looks very simple, but it's very complex for us because we need to fetch the right data to show the number of seasons for that specific show. And when the user taps on that, we show a modal which allows the user to select that season. And when the user does that, we need to propagate that information to other UI components that might care about that data. So here, there is a lot of code that is involved with this Android view. And we need that thing in a lot of other places. So these are another examples where we need the exactly or similar UI for the same component. The way that we did that is that season selector is one line of code. If you have in fragment A or fragment B, you just copy that line of code that instantiates the component, and then you have all the functionality, all the data that's out there. You don't have to do anything else. And we have all the coverage in the unit test that will test that component individually. That will make sure that it works and it doesn't break. So let's pause a little bit and think about the Google Android architecture components. I really like the name. Architecture components, it's very cool. It's similar with the stuff that we are trying to do. Let's see what they have. They have live data, they have view model, they have room, and now they have UI components. Do they? No, they don't. So there is no UI components in the architecture. However, there is a paragraph in the documentation that states that by using lifecycle-aware components, you can move the code out of the lifecycle methods into the components themselves. What they are saying is you should get the code that is related to that component that you are implemented, and that code should live in the component itself. It should not be in the fragment. So let's talk about what ideally is or should be a UI component. So ideally, it is reusable, it is testable, and it's independent. One component doesn't know about the other components that you have in the screen, and you can compose a screen using multiple components. We created an idea of a UI view, and what it really means is it's a wrapper for Android views. Instead of just calling that views, we are calling UI views to differentiate of the Android views. And it might have a model. In the example that I just showed you, the season selector one, that component is responsible for fetching its own data. Because in the screen that it lives, nobody else cares about the list of seasons. That's the only component that cares about that. So it fetches for itself and it renders itself based on that. Let me talk a little bit about the responsibility that we have. We try to use the single responsibility principle, and the main responsibility of a component class should be on the UI logic and the presentation logic, the business logic. All this logic should not be outside of it. The component should own. And also, it manages the state of the view. So if you have multiple Android views, this component will hold it, and it will change the state if it's required. The view will be completely stateless. And it also manages the lifecycle. It does that in a different way, but the idea here is the component knows when the fragment or the activity is gone, and then it's not going to invoke the view to change the state anymore because it knows about the lifecycle. It's similar with the idea of the live data and the view model that it's lifecycle aware. And then we have the UI view, which is a simple wrapper of a class where its main responsibility is to inflate its own XML layout. So the UI view is the one that represents a small portion of the screen. And then you can have an XML that it's only that portion. You don't need to worry about complex layouting or anything like that. If your component has 3 Android views and you have to lay out that using a linear layout or a constraint layout, it could be it. And then it's going to inflate itself. It also will find all the Android views and keep references to that. That's the one that's going to change the state of the Android views, but it does not hold any state. It's completely stateless. The component class is the one that knows about the state. And then it provides an interface for the component classes, and it implements some animations. So the animation logic, it's a good place to put that because it's view-related. Now let me talk about the high-level architecture a little bit. So on Netflix, we are using 100% Kotlin in our consumer application. Everything new that we write is Kotlin, and we use a lot of RxJava. So this architecture with the components, we decided to use an event bus pattern. And to implement the event bus, we are using Rx. You could do the same thing with any other event bus technology, but the way that it works for us is we have the fragment or the lifecycle owner, and this fragment is going to send events. It's just going to send events based on the state. If the fragment is fetching the data, or if the fragment has the data, it's going to send, oh, the data is here. Or if the fragment is for the player example that I just showed, the fragment is the one that has the player engine. And then it knows when the player is buffering, or when the playback starts, or all these things. And then instead of keeping references to other things, it just shoots an event using an Rx observable or a published subject. And then all the components that are initialized by the fragment are going to observe for these events. And the good thing about that is the component only need to observe for the events that it cares about. It doesn't need to worry about the other ones. And then it keeps very simple. You can have the business logic and the presentation logic in a very simple manner. You don't need to handle all the possible events because you can just ignore that. So if component 1 doesn't care about event A, it will just ignore that and react when it's required. That's how we implemented that initially. But there is one thing about Rx is if you have 100 components, or if you have 100 things that are subscribing to the same observable, the way that Rx works is you send an event, and it will loop through every single component to deliver that event. Even if the component ignores that, if it filters out that event, the loop will still go through. And we have some very complex screens in order to, oh, I'm sorry, I jumped through, but I will go back to that. So we have a very complex screens that have lots of components. So that's the second approach that we took. Instead of having one single bus that we use to deliver all the events, we can have a flexible way of having component events that will go only for that component. It doesn't need to go all the components, and that allows you to be faster. If there is one event that only component 1 needs and cares about, we are going to use a bus that will deliver only for that component. And then it optimizes a little bit. Now let me go back here and talk about the user events. So I spoke about the state events, but what happens if the user taps in a button, or if the user touches or drags something in the UI? The idea is the UI view has all the references to the Android views. And then it doesn't need to have any business logic. What happens is when somebody taps in a button, we shoot an event from the UI view. Somebody tapped me. I don't know what to do. And then there are two options. Or the component class knows what to do with that event, or that event can be sent directly to the fragment that owns that component. And the use case for this is everything that you need the fragment to execute. If you need to start a new activity, or if the fragment owns your player engine and you need to stop playback or skip forward or back, that's how it will work. The UI view will shoot an event, and the fragment will observe to that event, and it will do whatever it needs to do. That eliminates the need to have complex business logic inside the views. And that's the same thing for, oops. Let's go again. And that's the same thing here. So you can still send user events. So how we implemented this bus mechanism that we use to deliver events? What we did is we created a class called RxEventFactor. And what this class has, it has a map of lifecycle owners and a list of observables, a list of buses that will be used for that lifecycle owner. And this is the class that will be lifecycle aware and avoid sending events if that lifecycle says that the fragment is gone, or if the activity is not valid anymore. So you eliminate all the problems that you need to check, is fragment still valid, otherwise it's going to crash if you try to do something. So this Rx event bus factory will take care of that. And here's an example. Let's say that we have one owner that supports 2 types of events. It means that we are providing 2 buses to be used for that lifecycle owner. And that lifecycle owner will have a lot of components that can use these buses. Or you can have the same T1 for owner 2 and another T3. Or you can have a lot of buses to optimize if your UI is complex enough and you want to gain some performance on that. And that works for the basic case as well, or the one that you use one bus to send an event. That scales very well. And we have the source code here if you want to check this out. We used Kotlin extension functions. We added some stuff to the lifecycle classes. And it's pretty simple, but it's very powerful. So let's take a look in the code. Let's take a look at how the code for UI components will look like in this architecture. So here I have a fragment, and when I create on the onViewCreated method, I have a container. And the idea is your fragment, it will have an XML that it's an empty container. It will have a constraint layout or a linear layout or whatever you decided to use as the view group. And then when you get that here, the only thing that you need to do is instantiate a component. And you don't even need to keep a reference for that because the subscription of the component in the Rx will keep it alive. It will not be garbage collected. So there are no references needed for the component here in the fragment. So the 2 things that you need to pass is you pass the container that you want the component to inflate itself in, and you pass the event bus, the one that I just showed to you. And the event bus has the owner, which is the lifecycle owner. In this case, it's the fragment itself that we will use to take care of when the fragment is gone. You don't need to send events anymore. And you don't have to worry about that in the component code because you are guaranteed by the event bus that invalid fragments will not happen. And here there is one thing that I said about the UI events when the user taps in a view. You can get directly from that component an observable that it provides to you and subscribe to it to handle the taps. So in this case here, this is a player fragment which owns the player engine. So when the user taps in a button to play something in the UI view doesn't know anything about the player engine. You don't need to pass reference around or anything like that. You are only saying, oh, the user tapped in this button. And then here we are going to handle, okay, let's start the play. And that's pretty much it. That's how simple the fragment is. There is nothing there. Only instantiating and only the components. Now let's take a look in the component code, how it will look like. So it gets the container, which we call a parent here. And then the component itself will instantiate its own UI view. And it will pass exactly the same thing for that. We are going to take a look later how the UI view looks like. So here we have the event bus. We start to listen for state events or for screen events. And in this case here, what you can see is we are listening for playback events that are being sent from the fragment, because the fragment owns the player engine, or it could also be sent by the player engine itself. It's just an implementation detail. And what we do here is when we get a play started event, we want to show the UI controls, because that's the behavior that we want to have. When the playback starts, the loading is gone, and we show all the buttons for the player. And if we get a buffering, we want to hide the UI. If the UI are the buttons that control the player. But if this was the code for the loading component, we are going to do the opposite. We want to show the loading component when it's buffering, and we want to hide the loading component when the playback starts. And then we can isolate the logic. We don't need to have a giant switch in the fragment that tells, okay, so it's loading, let's see which are the views that we need to show, which are the views that we need to hide. And you might forget one, and you have an inconsistent state. So, and also here, it's very testable. In order to test that, you can send events and verify if your views are reacting accordingly. Let's jump to the view. So the view, what it does is it will inflate an XML that we wrote for that specific view. So in the example that I showed to you, if we think about the controls that we have in the center of the player, it's an XML that has 3 Android views, and that's the ones that we inflate here. That method that we have here, inflate and add, is just an extension function that we wrote in Kotlin and added for a view group that we can inflate something and add directly to it. And then in the init of this component, we set the click listeners if it's needed. If the component doesn't have anything to be clicked, that's totally optional. And here is what I mentioned before. If somebody taps in a button, we are not doing any logic. We are just shooting an event. Somebody tapped me. Whoever needs to know what to do, do it, because the event is now sent. And we expose some interfaces for the components to use, implementing the animations as well, if it's required. And that's pretty straightforward. Now, if you go back to the component, you can see that when the play started, we are invoking the UI view.show, and we show that component. Now, let's talk about something that it's very important for us, unit testing. So I'm pretty sure everybody here do a lot of unit testing, right? Yeah, we are starting to do that a lot now, because we created something that makes it very easy. One thing that we learned is if it's hard to write unit tests, nobody's going to do that. People are just going to ignore and test manually, and it's a lot of effort to write unit tests. But with this architecture, it's pretty easy. You can write unit tests super fast. And here is an example. I have a component that I want to test. I am going to instantiate that. I will instantiate my component, and I will mock everything, because I don't really care what the things that I'm passing to it will do. Then I will write the real test. What I'm doing here is I'm faking an event. It's not a fake, it's a real event, but I'm emitting that from my unit test. So what I'm saying here is this is the exactly same event that your component is going to get from the fragment, but I'm forcing it to you, and I don't need any dependence. I don't need to instantiate a fragment or to do all that craziness. I just come here and I send an event. So what should happen when we send a loading event to this component? Anybody? We need to hide it, because this component here is a button that we show in the player. And when the player is loading, we don't want it to be in the screen. So what we are doing here is we are checking if the UI view of that component.hide is called once. And we also want to make sure that we are not showing it. And we are saying the show should be called 0 times. And this is how we test that. Now think about the loading screen. What we want to do when we send a loading event to the loading component. Anybody? We want to show it. And we show that because the loading component needs to show up when the player is loading. And when the playback starts, we hide it. There is no component in the screen anymore. And that's how we test that. And it doesn't like for some reason. All right. OK, let's talk about layout. All these things are very cool, right? Because the components are independent, and they don't need to worry about complex layout or anything like that. But you still want to lay out your UI. You have a screen that you can compose using multiple components, and you need to lay out that component somehow. So as I said in the fragment owns an empty container. And that empty container is what we pass down to all the components. If we have a very simple screen, we can just pass a linear layout container. In every single component that you instantiate, it will be properly laid out inside of this container, and you don't have to do anything because it's a linear layout. Every component that inflates itself will add, and then you are going to have a result like that. But that's a very simple example. If you have a complex screen, as most of the real-life screens are, you probably want to lay out that accordingly. So you could have a constraint layout as the parent, and then every single component will inflate itself inside this constraint layout. But how about, how do we align that? How do we say that I want component 1 in the left of component B and all these things? Because the components, they don't know anything about each other. They are completely independent. So that's a job of the fragment or whoever the lifecycle owner or the screen that you have, the screen controller, or doesn't matter how your architecture is. But somebody that instantiates these components will be able to lay out them accordingly. And we do that using programmatically using constraint sets here. You can see an example. Every single component exposes a container ID interface that you can get its main ID. And then you can use that to set the constraint sets programmatically. What I'm doing here is I'm saying that my components.container ID, I want to align that in the top of the parent. Then it's going to the top. And this is something that needs to be done outside of the components to also contribute with the reusability. Because you can use the same component in different screens, and you might want to lay out that differently. So that's why the code doesn't live there. OK, I have 4 takeaways from this session that I want you to keep in mind. So the first one is think about this idea of UI components. Doesn't matter the architecture that you use, if you use MVP or if you use MVVM or whatever you decided to use. This is an idea that you can incorporate in any architecture that you have. It could be using the same thing that we are doing, using an event bus, event-driven architecture, or you could just call interface and callbacks as the old-fashioned way. But you still can have something like that, and that will contribute with your testability and reusability of your application. And the second one is try to keep your fragments clean. Ideally, the fragments, they should own the lifecycle, and they should take care of what happens on create, on destroy, or on saved instance state, and all these things. And you don't need to have presentation logic there. You can put this presentation logic in a component or in another thing that you have. And the third one is try to not pass fragments around. It's OK if you pass a reference to a fragment to another class if nobody holds to it. But some people will. And you cannot control that. If somebody holds a reference to that and the fragment is gone, you are going to see all the exceptions that I'm pretty sure all of you have seen that before. So don't pass it around. The components don't need that. And the third one is download everything that you want today and tomorrow, and then you are going to have a good flight or a good commute back. I have a GitHub. You have 5 minutes to ask questions. I have a GitHub repo that you can take a look in some examples. So I have two examples there. One, it's a very simple application with different states, loading, loaded, or error, and you can see how to use components to implement something like that. And I also have a very simple player that I wrote from scratch with a very simple UI, and then it can have an idea about how we wrote our player. And thank you. I'm open for questions.
So the thing that I saw that was, I had a curious about how you were managing this is when I saw you use the Rx event bus and how you were bifurcating all of the different events by types that were generics, which essentially means you're making empty classes which are acting as your different types. But when I think about that, I think of like there are hundreds of different types that you could possibly mean, which means you're going to have like a huge code base full of just empty classes. I'm wondering how you guys are dealing with that, because I can imagine that'd be really hard for maintenance down the line.
Yeah, you're right. We are using generics for the event bus. The way that we try to model our event types is we use sealed classes from Kotlin, and then we create like player events. And then inside that sealed classes, we declare all the events that are available for the player. And you can have another type that it's for another screen that you have, and you declare all the events that are available for that screen. And in the end, in the bus, you are going to have one type per screen. That's one way to model that, but it's very flexible. If you need more types per screen, you can do that. All the types that we model are all using sealed classes in Kotlin.
I was curious what parts of these are dependent on Kotlin versus being able to do them in Java.
Yeah, nothing is really based on Kotlin. I mean, we wrote that in Kotlin because Kotlin has some cool stuff like the sealed classes that are very nice to define the event types that we use. But you can do that in Java. If you do that in Java, you can have classes that will be your event types, and then in the example that I showed you that we have a switch case. If event is this type, the code in Java will not be super clean because you are going to have to do a cast to verify if the class of that event type that you are sending is the type that you want. But everything is totally possible to do in Java. It will just require more lines of code. How do I do A/B tests? If the layout is changing or if the components themselves. So if the layout's changing and you already have components, it's pretty easy to do, right? If you need to add a new component, you just write a new component and you can add to that layout. So you can extend the base class that you have that is instantiating all the components, and then you extend that for the test, and then you do differently. So in your test, you might not have a button or you have an extra button, and then you can just extend using inheritance and plug that in. If you need to test the component, you could do the same thing. You could extend that component and change whatever you need to change for that A/B test. And then you use a variation of that component. If you need to change a little bit, it's totally okay. You don't need to rewrite the whole thing. You could, right? You could use a different fragment, but the way that we do that is our fragment owns a UI class. And this UI class is the one that will check the A/B tests and instantiate the components accordingly, based on which test you are and which experience you are assigned to.
That class will take care of laying out.
Yes, that class will take care of laying out, but it's just an abstraction. If it's simple enough, you can have that in the fragment.